Right, I suppose I'll give an introduction at the end. So just for any of you who mightn't be from this is my school or whatever, we'll cover the name of the school there. But just with the state of coronavirus in Ireland at the minute, I'm just doing videos based on homework exercise. So a lot of this is based for junior cert, higher level. The class is a mix of higher and ordinary level, so we'll be doing some of the ordinary level stuff. But it's out of your Text&Test 2, the higher level book. At the minute we're working on trigonometry, so we'll be doing a few exercises out of the book and also out of your exam papers. So if you're just happen to be flicking by and tune in, welcome. Yeah, so have a look and learn something, maybe, hopefully. Alright, class, how are things? So first of our video tutorials, I suppose. Alright, so starting off here, we've page 442, and we're going to just have a look at question 7. Alright, so again, trigonometry, all based on right angle triangles. So this is simply working through, and each case you can see here, where actually x is the hypotenuse. So we're going to find the hypotenuse x in each of the 3 cases. So first things first, you want to label your sides. Alright, so 90 degree angle, side opposite your 90 degree angle is always your hypotenuse. Look at your angle then in question, so your 42 degrees, side opposite is O, and then you've got your adjacent. Okay, so now with our 3 sides labelled, you're looking at, well, what ones are dealing with? Well, x is the unknown, the one we want to try and find. We have 8, we don't know what our adjacent side is. So we have O, we want to find H. Which of our 3 values? Silly rhyme, silly old Harry, caught herring, thrown off America. Silly old Harry. Okay, so it is sine. So it is sine of the angle of 42 degrees. Silly old O all over H. So it's 8 all over x. Now, x is part of the fraction. We want to find the value of x. So we have to get x out of that, or isolate them out of that fraction. So what we're going to do is, x is the denominator, we're going to multiply both sides by x. Alright, so on the left you have x, take our sine, 42 degrees. Multiplying and dividing by x will cancel, so we're just going to be left with 8 on the right hand side. So again, when I multiply and divide by the same number, they cancel each other out. Okay, now we've got x out of the fraction, but he is part now of a multiplication. We don't want him as part of anything, we want him on his own. So to get rid of the multiplying by sine 42, we will divide both sides by the sine of 42. So multiplying and dividing, again, they cancel each other out. So on the left, we simply have x is equal to 8 all over the sine 42 degrees. And we've now put that into our calculators. So and again, we have to give these to the closest single decimal place. So we're going to get x is equal to 11.9558, rounding that up to 1 decimal place, x is equal to 12. Pause now and look if you're unsure. And I would say if you didn't get the following 2, it is the exact same for the next 2. So just pause this now and attempt these 2. Or if not, we'll take that you're happy. So label hypotenuse, opposite side, adjacent side. Which of our trig values are we dealing with? We're dealing with A here, H. Which of our trig values? It is cos. So cos of the angle 51 degrees is equal to cot a herring. So it is 10 all over x. Exact same as what we had over here. X is part of our fraction, so we need to isolate our x out of that. So we're going to multiply both sides by our x. multiplying and dividing on the right, cancel the multiplication of x. Alright, again, x now is tied as part of the multiplication. So we want to do the opposite operation to multiply, and that is divide. So dividing both sides, we'll end up isolating our x. X then will be equal to 10 divided by the cos of 51 degrees. So x then is equal to 15.89, rounding that up, 15.9. And again, you will give units if you're given units. We're not, we're just given lengths, so we just leave it as it is. So this one here, not anything different. The triangle is just rotated a different way. Looking at our 90-degree angle, the side opposite our 90-degree angle is always our hypotenuse. So x is, in this case, is our h. Look at your angle in question. The side opposite is always your opposite, and the third one is A. So again, we have O, 18, and we want to find H, which is going to give us sine. Silly, old, Harry, so it's 18 all over X. Again, exact same as we've done before. We want to divide both sides. That's 9 and 73. So 18.82, so just 18.8. Alright, that's that one. Thank you. Right, so continuing on, question 8, right, nothing to this, right, this is easy, really. You've got two triangles inside making a third larger triangle. The only difference is that on one of the triangles, you actually don't have any lengths at all, alright, but on one of them you do. So my guess is we're going to start with this one, use this to solve for x. X then is one side, and we can use x then to figure out what y is. Alright, so dealing with the triangle on the left, and remember, 90-degree sine, 90-degree sine. This is a right angled triangle, that is a right angled triangle. Alright, I don't really care about the overall larger one. Okay, so smaller triangle first, label the sides. 90-degree angle, side opposite is always your hypotenuse, h. Then you look at your angle, 62 degrees. Side opposite, x, alright, is O, your opposite. And then 8 is the adjacent. So we're looking which of our three values now has A and O, right? Because we know the value of A, we want to find the value of O, the opposite side. Okay, so cos, caught a herring, right, trawling off America. And silly old Harry at the start, right? So O and A is tan, so it's tan of our angle of 62 degrees. Trawling off America. Alright, simpler than the last ones. All I have to do now is x is tied up in the fraction here. I want to get rid of them, so I'm going to get rid of the division of 8 in the fraction and multiply both sides by 8, and then we'll isolate x on its own. So multiplying by both sides, x is equal to the tan of 62 degrees, multiplying and dividing by 8, cancel each other out, and I'm simply left with x. Into your calculators, 8 multiplied by the tan of 62 degrees, and I'm going to get 15.045 is equal to x. And do we have to round that up or down? I don't know. It's nearest whole number. So nearest whole number, x is equal to 15. Now, using the fact that we now know what x is, alright, so we now know that x is 15. So we're going to remove x, and I'll include them in there as 15. Alright? Or just put it in, if it was E in your copies, just put it in pencil or something like that. Now we've got another right angle triangle, so we now again need to relabel our sides. Alright, so this is our 90-degree side, our angle. This is the side opposite, always your hypotenuse. This is the angle in question for this larger triangle. This is the side opposite, so it's remaining O, and this is A. So again, we have A and O, tan. So again, we have tan of the angle, this time is 37 degrees. So tan 37 is equal to drawing off 15. America is Y. Alright, extra step this time because your unknown is in the denominator, you have to just do an added step for this one. Multiply both sides by Y to isolate the X, or the Y should I say, out of your fraction. So we're going to get Y multiplied by tan 37 degrees. Multiplying and dividing by the same number will cancel each other out, so that's all equal to 15. Y now is tied up as part of a multiplication we want to get rid of and isolate it, so we're going to divide by the tan of 37, both sides. So Y is equal to 15 all over tan of 37 degrees. So we're going to get, on our calculator, is 15 divided by tan of, what is it, 37. And you're going to get 19.9 to the closest whole number is going to give you 20. So Y is equal to 20. So X is 15, Y is 20. And there shouldn't be really anything that will complicate you in that one, only that we had to maybe see that we have two right angle triangles within a larger triangle. Alright, so slowly getting used to the sound of my own voice. But anyways, so there were two of the questions there from page 442. Now, the 9 and 10 were the exact same, so I'm not going to bother doing those. So we're going to skip on ahead now to page 445. Question 2 with the diagram of the tree there. Again, you've got a right angle triangle, you have an angle, a side, you have to find the height of the tree, basically call that side X, look at which your trig ratios you need. Very simple, so there should be no reason. Again, this one, there shouldn't be any reason, so 102 you had commented or wrote that you actually got a lot of difficulty in all of these questions. These are asking you to visualize. Remember, what is trigonometry? Trigonometry is based on what type of shape? A triangle. What type of triangle? A right angle triangle. So you're trying to create a right angle triangle out of what you have in front of you. Okay, so we're out at sea, we've got two boats and this point R. Alright, and we're asked to first of all find the distance QR. Remember, two straight lines in between two letters mean the distance from Q to point R. So basically R, Q, we're going to look at that distance. Alright, so imagining this ship is probably going to end up sailing to point R. So what have you got? A right angle triangle. You know two sides. How can you get the third side? Yes, Pythagoras. Well done. Okay, so Pythagoras said that the square of the hypotenuse, 90-degree angle, this is our hypotenuse. So we're going to call this side X. So X to be squared, the length of it. X squared is equal to the sum of the other two sides to be squared, 54 and 112. Alright, so again, Pythagoras, the square root, or the square should I say, of the hypotenuse is equal to the sum of the square of the other two sides. So we're going to get 54 squared plus 112 squared. So these two numbers squared and added together is going to give us 15460, and that is the length of X squared. Alright, how would I get the length of X? Get the square root. Square and a square root cancel. So the square root of 15460, so X is equal to square root answer 124.338, and we're told to give it to the nearest whole number. So to the nearest whole number, so 124.3 is going to be left at 124, and in this case it is kilometers. So make sure you include your distance. So now I fill in here x to 124 kilometers. So part 1 done. Now we're asked to get the angle P or Q. So might it be nice to label that angle? Good. So starting at P, going to R and finishing at Q. So starting at P, going to R, finishing at Q. This is the angle we're talking about. So we'll call it A. That's the angle A up there. That's the one we're trying to find. So how do we read an angle? So an angle P or Q. We start at P, go to R and end up at Q. P or Q. Creates the angle in between these two ray lines. So we want to find the angle A there. How do you do it? Trigonometry, alright? Because what are we dealing with? Right angle triangle. You know sides, alright? So we'll label them up. So H here, opposite your 90 degree, is always your hypotenuse. This is the angle in question, so this is always O, and this will be A. So which value do you want to use? We'll go for the first one there, which is sine. So we're going to sine the angle A. Silly, old, 54, all over the hypotenuse, 124. So silly, old Harry. Alright. Sine of some angle A is equal to this fraction. How do we get the value of the angle? We use our inverse function. So sine inverse of the angle will equal the value of the measure of that angle A. So onto your calculator, shift sine, is going to get you your sine inverse, then you're going to go your 54 all over your 124, and that will equal 25.8 degrees. Alright, and again to the closest whole number, rounding that up, 26 degrees. So just think about this now, because the questions that you're going to come across, you're going to have to think. Alright, they're not just going to jump out at you off the page. Think about it. You have, for part 1, we had a right angle triangle. You were given 2 sides, you had to find the third. Alright, when you have 3 bits of information and 1 unknown, you can use the other 2 to help you find the 3. So Pythagoras, square the hypotenuse is equal to the sum of the other 2 sides to be squared. We worked out the length. Alright, using that, and I could use any of my trig ratios here, alright, but this is the angle that I'm trying to find, so I need to identify the angle, label the angle, then use trigonometry. So I labelled my other sides. Because I had all 3, I was open to be free and happy to use any of my ratios. I just use sine for the first one, so 54 all of 124, inverse function then to find the value of A. Look at your notes, we have this 26 degrees to the closest whole number. Alright, so moving on to question 6, and again what we said was we have to focus on making right angle triangles out of the given figure. Alright, so I'm thinking about Ellie here on this one, right? Sure to God you can tell me now where we've a right angle triangle in this bit of a swimming pool. So are we sinking or are we swimming? Well, if we look, make up our right angle triangle. Drop a line down here. Continue this out here. Alright, we have a rectangle. What is the angle in the corner of a rectangle? 90 degrees. Do we know the height of the pool? We do, 2.5 meters. Do we know this measurement here? Yes, we do. We know from here to here is 50, here to here is 14. Well, 50 minus the 14 will give us this height here. And we're going to use the fact that we know these two sides then to work out the angle theta in this case. Alright, so hopefully you can distinguish between the blue and the black here on the screen. But right, 2 in there, 2.5 meters here. Alright, so we're going to get 36 meters here, and then that's the angle theta that we're trying to find. So we label our sides. Looking at our 90-degree angle, the side opposite our 90-degree angle is h, your hypotenuse. Angle in question, all the side is O, and then the third is always your adjacent. So we've got O, H, we don't really need to worry about, and A. So silly, old Harry, caught a herring, trawling off America. Alright, so it is tan. So it is tan of the angle theta. Remember that symbol there, that's theta. So tan of the angle theta is equal to trawling off 2.5. America, 36. Alright. Again, we want to find the angle. Anytime you're trying to find the angle, we want to think inverse function. So tan inverse of our fraction of our 2.5 all over our 36 will equal the value of theta. Alright, and again, fire that into your calculator. So shift tan will get you your tan inverse 2.5 all over 36, and that is going to give me 3.9724, so is equal to theta. And if it's close to the closest whole number to the nearest degree, so it should be 4 degrees is equal to theta. Alright, so only tricky bit of that was to visualize a right angled triangle. Alright, even if you didn't go doing it this way and drawing it in that way, you should have been able to see, well, I can take a vertical height here. So imagine you just took a slice. Alright, so you know that height, you know that height, okay, and kind of mirror it down so that your theta is in the inside of the triangle rather than the outside of the triangle. Now you could have done it the opposite way. You could have got this angle in here, call it something else, alright, call that x, and then you know that that is 90, so this would have been, what do we get, 86, and then you would have taken it away if you wanted to do that. A bit more complicated, but the first way is fairly straightforward. Alright. Right, so this is the question 9, alright, so we've skipped 1 or 2 of them there, and it's going to be the last one that I'm going to do out of this particular set of exercises for you, because I think they're all the same. After you go through these steps, they're all the same. Alright, so in your book, Susan is out swimming. I'm going to change Susan to Miwash, because Miwash still hasn't joined our Google Classroom, so can you get word out to him that he's late with this assignment first of all, and he needs to be joining if he wants to actually learn now. He's missed a bit from being away on holidays. So we've got a wall, we're told the height of the wall. We know from the wall to the water is 8 meters, and then we've got Miwash out here swimming away. Alright, and the question stands is, how far out to sea is he? Alright, somebody from the wall then measures, and they figure out the angle of depression from the top of the wall to the swimmer is 6 degrees. Alright, so we need to figure out, well, what is the length? You know, the question that's been asked is, what's this distance here? But I'm not inherently worried about that just yet. I want to find from the swimmer to the wall. If I do that, I can create a right angled triangle. My 90-degree angle in here. So, do I know the height? If I just sketch out a right angle triangle out here, there's my right angle triangle. Do I know the height here? I do, 2.1 meters. Alright. Do I know any other length? No. what length do I want to find? This top one here, x. Alright. Do I know any other information? I do. I know the angle of this up here is 6 degrees. So, using what I have, can we work out that length x? So, 90-degree angle, this is our hypotenuse h. Alright, this is the angle in question, so the side opposite the angle, this has to be A. So, we're going to look at, well, we have O, we have A. Which trig values uses that? Well, it is tan. Alright, so tan of our angle, which is 6 degrees, tan of the angle is equal to throwing off America. So 2.1 all over x. Alright, I want to find the value of x. So multiply both sides by the denominator x. I'm going to get x multiplied by tan of 6 degrees is equal to 2.1. Alright, we don't care about this multiplied by this, we want to know what x is on its own. So if I divide both sides by the tan is 6 degrees, then I'll get x, its value. So 2.1 all over tan, 6 degrees, again, into your calculators. So, small reading slow. I know these questions are taking a couple of minutes to actually go through on video and all that. So, small little bit slower than maybe what we're doing in class, but look, you have them. You've reference material here. I suppose it's a bit of a novelty for while we're at it. So 19.98 meters. I'm guessing closest meter. We're here to the nearest meter. Yeah, so that's going to give us 20 meters. So x is equal to 20 meters. That's not what we were asked to find. We're asked to find how far is Mirosh out to sea. Alright, we know the beach part is 8 meters. This is the remainder. This is how far they're out to sea. Well, if from here to here we worked out as 20 meters, 8 from 20 will give us 12. So the distance from here to the person out swimming is 12 meters. Alright. Yeah, so look, it's all about creating right angle triangles out of what you're given. Alright. Questions coming up now in the next section are a little bit harder. There's more thought to go into them. Alright. So I don't want you just saying, geez, I haven't a flipping clue how to do that, I'm just going to leave it. I'll wait, then he'll throw up a video and I'll see, oh yeah. Everybody knows how to do something once they're shown it. Alright. Can you figure it out yourself using what you already know to solve a new question? That's what you need to look at. Alright. How have I done anything different in any of these questions? No. Right? I have used my trigger ratios. I have created a right angle triangle. I'm working through that. If I need to find the angle, I use the inverse function. So, two basic things. Angle, use your inverse function. If you're trying to find lengths of sides, you just use your ordinary trigger ratios. And again, back, if you've got two lengths out of a right angle triangle, asked to find the third, Pythagoras. Alright? Enjoy the evening and we'll chat to you again later.